In the United States, the Census Bureau does a population survey regularly, and here's the site for information about this current population survey. And there's information about how they do this, and I want us to take a quick look at that before we launch into things. So this methodology, while this loads, let's see. So this survey is administered by the Census Bureau, and they select tens of thousands of households and ask a lot of questions. And so there's this questionnaire, and they do this regularly, and there's information here about what types of people are eligible and how this data is collected. And on the website, you can find information about what they got from this survey. And so for 2024, the most recent data is from February, and you can go back and look at previous months. And so what we're going to do is look at some recent data. I'm just going to choose October of 2023, and we're going to download this CSV file, and we're going to look at it and try to use this sample to say things about the US population. So we're going to look at this census data from October of 2023, and first we're going to use this sample from this data set to estimate the average number of hours worked per week in the United States among people who worked a positive number of hours. And then we're going to look at the sample data to estimate the proportion of households in the US in which someone owns a business or a farm. And so we're going to use these formulas that we have for confidence intervals to estimate this average and estimate this proportion. And so for estimating the average number of hours worked in part A, we're going to want to find the average in the sample, our X bar, and add and subtract our margin of error. And here we'll only have information about a sample, so we won't know the population standard deviation, but we could find the sample standard deviation, and we could find our sample size. And since we have a sample standard deviation, we'll use a t-value. And so this formula will give us our confidence interval that will help us have an idea of an estimate for the average number of hours worked. And then in the next part, we're estimating the proportion of households that have a certain property. And so we want the confidence interval for proportions. So we'll take our sample proportion and we'll add and subtract our z-value times our estimate for our standard error, which is the square root of our sample proportion times 1 minus the sample proportion all over n. And so these are the two things that we want to do using this data from this sample in October of 2023. So we want to make a confidence interval for the average number of hours worked. And so we're going to open up this data file from October of 2023. But before we do that, let's look at the data dictionary so that we can see what things mean what. And you might have noticed on the previous screen, I said to look at this column that's going to be labeled PEHRACT1. And if we look at the data dictionary, it says that that question is asking, last week, how many hours did you work at your job? And the valid entries are 0 to 99. And so that's the column that we're going to want to look at in our Excel file. So if you download that Excel file from October of 2023, and here I've opened it in Excel and saved it as an Excel file, in this document, I want to look at that column, PEHRACT1. So I'm going to search for that. It looks like that is column GB in Excel. And so looking at this column, this is supposed to be saying something about the number of hours worked, but a lot of these are negative. And so I'm making an assumption here that these negative ones are maybe coming from someone who didn't answer the survey or skipped that question, I guess I should say. If someone skipped that question, then I'm going to assume that's where this -1 is coming from, and the numbers that are non-negative are the number of hours worked. And that's an assumption. And something that is important to remember is sometimes if someone skipped the survey question, that might not be a totally random thing. Those might be values that are missing, but they might be related to other values in our survey questions. And so we might need to worry about why they're missing in general, but just for the sake of what we're doing here, I'm just going to kind of pretend that those aren't part of the data, that those missing answers or those -1 values aren't part of our data. And so I'm going to make a new sheet in Excel, and I want to start out by making a confidence interval for the average or the mean number of hours worked last week, worked per week or last week in the US. And I'm going to think about just cases where someone put something that was non-zero. So among people who work a positive number of hours per week. And just as a note, we're looking at that PEHRACT1 column. So what we need to do is we need to find our sample mean and our sample standard deviation, and we'll need to find our n, our sample size, and then we'll need to use all of those to get our confidence interval. I guess we also need our t alpha over 2 value. These are all things we need to get our confidence interval. So here, let's think about our sample mean first. So in Excel, I can do average and take the average of all my sample values to get the mean. And so I could do average, I could go back here, and I could select this first value, and I could hit Control-Shift down until I get to the end. And so if I do this, I can go to GB127940, and that will select that entire column. Great. So that's my sample mean. But you might have an issue with this because that was including a lot of values that were -1s, things that were probably missing, and might have included people who said they worked 0 hours. And we said that we only wanted to include positive numbers. So what I could do instead is I could do average if, and I still want to look at all of those values, but I only want the average of ones that are positive, that are bigger than 0. And so if I replace the average with an average if and put this condition that I want things that are bigger than 0, that will give me the sample mean of the actual values that I'm going to consider part of my sample. Okay, so that's a lot different. Among those values, without all those -1s and any 0s, my sample mean is about 37.59, or about 0.6. So now I want to do that same thing for finding the sample standard deviation. So if I was just finding a sample standard deviation, I would do stdev.s, and I would highlight all of my data. But I only want to do this for these values that are positive. So I'm going to put an if command inside of this, and I want the standard deviation of, again, these things in column GB from this previous sheet. So I'm going to select this one, and I want to look at everything up to GB 127940, but I only want to look at the cells that are positive, and if they're positive, then I want to take the standard deviation of them. And so I'm going to copy what I have entered right here. So I'm going to first check that that is positive, and if it's positive, then I want to include it and take the standard deviation. I think I need one more parenthesis there. Great. And so my sample standard deviation is about 12.5-ish. And then my n, I want to count how many of those values I was including in those previous two calculations. So I want to count, and I want a count if. So count, I'm going to kind of structure this as a count on the outside, and if this value, or these cells, if they're positive, then I want to include them, and I want to count how many of those there are. And so this should give me my n. Great, so my n is a little over 40,000. And lastly, I need my t-value, which will be t.inv.2t. And here, let's say we're doing a 95% confidence interval, and then we would plug in 0.05 as our alpha. And then next comes degrees of freedom, so we'll take our n and subtract 1. And so this will give us our t-value. Okay, so our t-value is about 1.96. And now we can use all of these to get our confidence interval. Let's maybe do one more step. And I'm going to make a note here. This t-value was assuming that we're finding a 95% confidence interval. But before we jump straight to our final confidence interval, let's maybe first find our standard error estimate. So that will be our sample standard deviation over the square root of our n. And then we can use that to find our margin of error, which is our t-value times that standard error. Great. So now we're ready. So now, if we want to find the lower end of our limit, or of our interval, excuse me, we will start at our sample mean and subtract that margin of error. And then to get our upper limit, we'll start at that sample mean and add our margin of error. And so this tells us that we are 95% confident that that average number of hours worked is somewhere between about 37.5 and 37.7. And so this is a confidence interval for that average number of hours worked, if we're only looking at people who worked a positive number of hours. And so this is how we could use those skills and all these tools that you have from previous classes to actually say something about an average from this real world survey, this population data about a sample. So we used our sample to try to say something with some level of confidence about a parameter for the whole population. Now we're going to look at making a confidence interval for the proportion of households in which someone owns a business or farm. So if we look at this data dictionary, column HUBS with that label, it says, does anyone in this household have a business or farm? And a 1 means yes, and a 2 means no. And so let's go back to Excel and think about how we would do this. So here's that column in Excel, and if we look at these, we have these 2s and 1s. And it looks like most of actually what's on the screen here are either 2s or negative 1s. So remember, a 2 means no, and a 1 means yes. And so a negative 1, again, probably means that person skipped the question. And we talked about the issues with just ignoring those values. But for the purposes of this, we're going to just ignore those values. And so if we're thinking about the proportion of people who own a business or farm, we would want the proportion of these values where someone entered a 1 as a yes. And so if I go over to this sheet here, we're looking at trying to make a confidence interval for the proportion of households in which someone owns a business or farm. And so what we're going to need is our sample proportion, and we're going to need our estimate for our standard error, which will involve our n, our sample size. And let's say that we want a 95% confidence interval, then we'll also need our z value. And for this, again, we're going to assume that we're finding a 95% confidence interval. So let's try to start with our sample proportion. So we want to count up the number of cells that have ones in them and divide by the total that we're considering. So there are different ways that we could do this in Excel. Let's do it using the COUNTIF function instead of an if placed inside. So we want to count if, we want to first count up all the values that are equal to 1. So we're going to select this first one. We want to go all the way to, this is column J, and so we want to go all the way to J 127,942. And we want to count up the ones that are equal to 1. So that's the first thing we want to do. I'm just going to copy paste this thing that we're looking at, these cells that we're looking at. And then we want to divide by our total. But if I'm just going to ignore the people who skipped it, I don't want to include those -1 values in the total. And so I'm going to divide by COUNTIF of those cells, and I'm going to divide just by the number that are positive. So I don't want to include those -1s. And you could also, instead of positive, since we expect them to be either 1 or 2, you could divide by the number that are equal to 2. That would also work. I guess equal to 1 or equal to 2. So we'd have to add up 2 terms. So greater than 0 is a little bit simpler. Okay, so this right here will give me my sample proportion. So this means that about 12.9% of the people who responded own their own business or farm, or someone in the household does. Next, we want our standard error. So here, for proportions, standard error is the square root of our sample proportion times 1 minus our sample proportion divided by n. Well, we haven't found n yet, so this is going to give me an error. So I'm just going to leave it here for now. So to find n, we'll need to do COUNTIF, and we want these cells that we were looking at, and we just want the ones that are greater than 0. We want to count and see how many that actually was that was in that denominator for the sample proportion. Okay, now that we have that n, we can go back and find this standard error estimate. Great. And then our z value is going to be norm.s, since this is a standard normal, .inv, and the area to the left, if we're looking at a 95% confidence interval, that area to the left will be 0.975. So this will be our z value. So that means that we can use all of these to get our margin of error. And that margin of error will be the z value times that standard error estimate. And now we're ready to find our confidence interval. So for the lower limit, we'll start at our sample proportion and subtract the margin of error. And for the upper limit, we'll again start at that sample proportion and add the margin of error. And so this tells us that the proportion of households in which someone owns a business or farm, we're 95% confident it's somewhere between these two numbers. So this top one, if I round, is about 12.7%, and the bottom is about 13.2% if I round up. And so I am pretty sure that the percentage of households where someone owns a business or farm is somewhere between those numbers. And again, I did make this assumption where I just threw out anyone who didn't answer, which might not have been a valid thing to do, but all of this is assuming that our sample was only made up of people who actually answered that question. And this can tell you something helpful about using this sample, what we think the actual proportion of households where someone owns their own business or farm, what we think that is. And we can use this to try to say things about the US population as a whole.